Welcome to this webinar, jointly provided by the IChemE Safety and Loss Prevention Special Interest Group and the IChemE Safety Centre. My name is Trish Kerin and I'm the Director of the IChemE Safety Centre, and I have the pleasure of facilitating this panel session with you all today. This webinar will be recorded and afterwards will be made available on the Safety and Loss Prevention Special Interest Group website, as well as the ISC's YouTube channel for anybody to be able to access and watch. You will have the opportunity to ask any questions you have throughout the webinar, and I'll direct you to use the questions panel in your control panel. And if you type those questions in, we'll look at how many of those we can get to as we work through this discussion. If you've got any other comments that you'd like to make, we have a chat panel. If you're having any technical difficulties, feel free to use that chat panel and I'll try to manage that and deal with those as well as we go through. So let's just set the topic for what we're talking about today. On June 1st, 1974, at around 4:53 p.m, a massive explosion occurred at the Nipro Flixborough site in the UK. 28 people were killed in this incident. A further 36 workers were injured and 53 members of the public injured as well. And almost 2,000 houses or buildings were substantially damaged or destroyed in the explosion. In the years since, much has been written about the incident and its technical causes. Flixborough is synonymous with the development of management of change as a process to address engineering and the engineering of the temporary bypass line, as well as starting to understand a lot about the location of buildings on facilities. But there were many deeper aspects to the incident aside from that we can learn from. Now, this webinar is not going to focus on the technical details. If you're interested in the technical details, there are many good resources available, and I will point you to some of those at the end of the webinar. So what I would like to do now is introduce our panel for today. Unfortunately, at this point in time, we're still awaiting Dame Judith Hackitt, but I will move on and introduce Ken Rivers. So Ken is a non-executive director of the Health and Safety Executive and a past president of IChemE. He's also a member of the Industry Safety Steering Group, monitoring the progress made by the built environment towards achieving culture change following the Grenfell Tower fire. Ken is a former chair of the COMA Strategic Forum as well. Ken's background is in the oil industry. He's a past president of the UK Petroleum Industry Association and chaired the Industry Regulator Task Force in the wake of the Buncefield terminal explosion. He also chaired the Government and Industry Task Force, which considered ways of improving the resilience of oil product supplies following government review. We're also joined by Ramin Turney. Ramin held positions in production and engineering in ICI before specialising in process safety as a lead or manager for hazard identification and risk assessment in the ICI corporate engineering department. He's a strong supporter of IChemE and has been a past chair of the Loss Prevention Board editorial panel and is currently on the Major Hazards Advisory Committee representing the Safety and Loss Prevention Special Interest Group. He's been the technical director of the European Process Safety Centre and has served on the Health and Safety Commission as well. Welcome, Ramin. We also have Ramin Abhari with us, and Ramin is a senior staff research engineer with Chevron Renewable Energy Group. He has over 34 years experience in the chemical process industry with expertise in hydrogenation and polymerization technologies. Ramin has held engineering positions with W.R. Grace, General Electric and ExxonMobil. He is named as an inventor in over 54 US patents and has co-authored or authored several peer-reviewed technical papers about bio-based chemical processes, renewable energy and fuels. He's also written and illustrated several graphic novels with industrial safety themes. Ramin has a master's in chemical engineering from City College of New York and a bachelor's in chemistry from the College of Worcester. He's a registered professional engineer in the state of Oklahoma and a senior member of AICHE. Welcome, Ramin. And I do believe that Judith is about to join us any moment, so I will actually go through Judith's introduction now as well. So Dame Judith Hackitt is a chemical engineer by training and spent her early career working in the chemicals industry, both in manufacturing and also as an advocate for the industry at national and international level. She's a former president of IChemE and a fellow of the Royal Academy of Engineering. Throughout her career, she has championed the importance of engineering in delivering solutions which provide benefit to society and has been a role model, particularly for young women wanting to enter the profession. She cares deeply about safety in the workplace and more broadly as well. From 2007 to 2016, she was the chair of the UK's Health and Safety Executive and in 2017 conducted an independent review for the UK government into building regulations and fire safety in the wake of the Grenfell Tower disaster. Since publishing her final report in 2008, she has continued to press for regulatory change and for industry culture change, and her recommendations for radical reform of the regulatory system received royal assent in the Building Safety Act of 2022. She's also currently the interim chair of the Office of Nuclear Regulation as well. So what we're going to be doing today is we've got some conversation that we're going to have about the legacy impact of Flixborough and the impact that it's had on various of the panellists. So I might actually start at this point in time and say, I'm going to start with you, Ken. How did Flixborough, when it occurred, shape your career in this field?
Yeah, well, it probably had the most profound effect of any of the incidents that have happened during my career. The event occurred while I was at university, and shortly afterwards, I joined a major oil company and started working on a refinery. And shortly after doing operations, I moved into major projects. And one of the key issues there was, following the impact of Flixborough, was the management of change. And it was profoundly interesting to see how change used to be sort of sorted out, or modifications sorted out, by people getting together in a little group, having a chat and then going off and doing it. And then seeing how, following Flixborough, the, if you like, systemization about how we would manage change, the forms we would start to fill in, the questions we would ask about competence, and the whole range of things around that actually just changed completely the way we do everything. Everything became a lot more focused, everything came a lot more, there's a lot more checking going on, there's a lot more auditing going on, there's a lot more focus on are you competent and things like that. The thing that impacted on me, though, was having experienced that fundamental shift then in how we actually did things, was then to say, well, actually, there's a group in ICI led by a guy called Trevor Kletz, who know a lot about managing major hazards. Ken, why don't you go up to Teesside and get on a course and see what those guys are saying? So I was sent up there, and to be honest, it was a life-changing experience. I met this guy called Trevor Kletz and his team, and I was exposed, you know, to an eye-watering array of potentialities for disaster. You know, going, oh my gosh, how does anybody handle this? And then turning around and then grasping how from that potential chaos, it could be converted into an orderly and structured management of risk. And, you know, it was like, you know, a door opened on the potentialities, which I'd not really experienced. That array of potentialities, that opportunity for disaster, and then to be confronted with a way of getting your head around that and managing it. And that was absolutely amazing. You know, to understand, you know, that chronic unease didn't have to be disabling, it could be energizing. And of course, to grasp that idea that the idea of inherent safety, what you don't have can't leak, you know, and those sorts of different insights. I think they're the biggest lesson, its impact on my personal conduct. I think Trevor was very keen, and I think the Flixborough lessons were also clear as well, about not asking for permission, but just doing what was right. And as a result of that, during my career, I've asked for a lot of forgiveness after the event, but I've never regretted choosing that path. And, you know, what I think is that Flixborough kicked off a huge change in our industries.
Yes.
It sort of got our heads around the fact that there was something called major hazards that were different from managing slips, trips and falls, to get our head around that. And it started a debate about how can we leverage this different insight, this different expertise to make radical change. And it was a starting point for that. So for me, that was the impact. It was huge, life-changing. Yeah, and made me what I am or not.
Thanks, Ken. Robin, from your perspective, how did it really impact you?
Yeah, well, I realise I've got quite a lot of experience on this panel. I'm probably the old man because when Flixborough occurred, I'd already been working for ICI for 10 years. I'd commissioned plants. I dealt with quite dangerous chemicals, liquid sodium, liquid hydrogen cyanide, phosphate. So I knew chemicals were dangerous. And I spent a lot of time making sure we kept those under control. And we've probably heard of in the ICI, unfortunately, we had an explosion within a vessel, so we knew about those. But to be quite honest, I for one, and I think very few of us, appreciated the severity of loss of containment and certainly vapor cloud explosions. I was working there, nobody ever told me about vapor clouds. I realised if you had a leak of a flammable, you get a fire, but not the kind of damage, the extreme loss of life at Flixborough, and the effect that it could have effects outside. So I don't think I wasn't alone in that. It really caused us all to suddenly realise we've got to take this subject a lot more seriously than we had been until then. It's good to hear Ken talking about the experience of ICI. In the early 60s, ICI did have a bad period. Nothing obviously on the scale of the incident we're talking to today, but we had incidents, and that led to the development of HAZOP. By 1970, it really was being applied to all new plants, which was good. Other people may correct me, but to the best of my knowledge, well, I don't think we'd even tweaked modifications. We were concentrating on getting the design right, and I don't think we'd thought about, hey, somebody else can come along and change a good design. But obviously we picked up on that very quickly. And I think the other effect, it made the whole industry start talking, rather than just ICI. It was ICI Shell, it was all the companies, and across Europe starting to say, we've got to talk about this and work on it together.
Yep.
Had an enormous effect.
Thanks, Robin. So, Ramin, from your perspective over in the US, so obviously we've heard from a couple of people based in the UK at the time. How did Flixborough shape your career from the US perspective?
Yeah, I heard about Flixborough for the first time in 1993. I was a young engineer working at a large US chemical company, and I stumbled upon Ralph King's book, Safety in the Process Industry, at our company library. And the timing was key. I had just returned from a 14-month assignment at a partner company's process demonstration plant, where creative workarounds were commonplace to operational issues. Chapter 4 of King's book is titled The Flixborough Disaster. And once I started reading it, I couldn't stop. King's in-depth account of Flixborough struck a chord. I could easily see myself and my fellow engineers at the demonstration plant making the same decisions as the Nitro team had, including fabricating a custom pipe stool to bypass a reactor. It was a sobering realization. Flixborough became more than just a chapter in the safety book. It became the foundation for developing my process safety education and competency in the years that followed.
Thanks for that, Ramin. I think that's really interesting. So particularly because, you know, we didn't necessarily see as much impact potentially outside of the UK at the time even. It's obviously a massive impact that happened in the UK, but perhaps it didn't filter around to some other parts of the world. I think certainly from my personal perspective, one of the things that I did see was I eventually in my career worked at a plant that was built in the late 70s. And it was an ICI built plant in the late 70s in Australia. And I believe it might have been the first major ICI plant that was built following the Flixborough disaster. And so we actually started to see some really interesting design and inherently safer design principles embedded into this plant. It was beautifully laid out. It was full of inherently safer design principles. And as such, it operated very well, and it was maintained, and it had a good management of change process to it, obviously, as well. So it was interesting that we sort of started to see that happen in Australia with that plant, and having also then worked in plants that just kind of grew. You could really see the difference between a designed plant with inherently safer design principles put in place versus the ones that just grew and expanded. And I also hope to have Judith joining us any moment as well. I want to look at what some of the key takeaways personally were for you in terms of, you know, I mean, Ken, we heard you talk about how your exposure to Trevor Kletz and to working in that safety world, but, you know, has there been one or two key takeaways for you that have struck with you throughout your career and led, you know, still with you today in the work that you've done in this major hazards area?
Yeah, well, I think there are, and I think, as you were saying, the issue of Flixborough was a start. Unfortunately, there were several incidents that followed shortly, which just reinforced the same issue, like Cerveso, later on Bhopal, and you know, it just went on. You know, Piper Alpha, you know, Texas City, Buncefield. It just goes on and on and on. So a start of a journey. But I think the shocking piece for me was the fact that one can be living a life and doing a career and thinking the world is fine. You know, the sun is shining, the grass is green, all the controls are in place, and we're okay. And yet the reality about process safety and the management of major hazards is we don't necessarily get those signals every day, immediately, that tell us we've got a problem. And so it's about preventing things that are rare but of huge consequence. And sometimes the signals aren't there. So the question then for me was always, we're on a journey, and it starts off in a place called unconscious incompetence, which is we don't have got a problem. And then all of a sudden an incident can come along like Flixborough, which tells us we have got a problem and we've got to change. So we move from unconscious incompetence to conscious incompetence. Hopefully what we've learned as we've gone through from Flixborough is that if we measure the right things, then that result might give us some confidence that we're in the right place. And then we might measure them again and they improve and we think we're okay, but they might decline, which tells us we've got a problem again. Or having got a good result and then found it's still improving, we then compare ourselves to somebody else and find out our level of performance is just not in the same place. So I think what has happened is we've then got, if you like, a structure, which is we can say, where are we? Are we unconsciously incompetent? Have we got the right measures in place and we're consciously competent? There's sometimes when we're in that unconscious incompetence place, I think the role of the regulator becomes absolutely vital, and we've got to understand that, because in that space you're doing something not because you know you've got a problem, but because somebody else is telling you've got a problem. And you know, one of the things I think we reflect on, particularly my new role as part of being a non-executive director of the Health and Safety Executive, is to understand the role of the regulator in these various phases of development. Now, I think the encouraging bit was post-Flixborough, post-Bhopal, post-Cerveso, we started to understand we had a problem, and then we got busy with implementing systems, processes, procedures, you know, all those things that we as engineers and chemical engineers are good at. And so we moved from that box of unconscious incompetence to conscious competence, you know, because we knew if we did those systems, we knew if we did those processes, we knew if we did that analysis of data, then we would have some confidence that if we kept doing that, we would deliver. I think the next step, of course, and the journey that we went on with other incidents, was also you only get to the level of performance that we need in managing major hazards if you build in those systems and processes into people and themselves, so it becomes part of their behavior. So that journey from unconscious incompetence to conscious incompetence, then onto conscious competence, then needs to go on to unconscious competence, where our behaviors, our values all underpin an activity which then will make sure that these very rare but hugely consequential events are prevented. You know, and I think, you know, within those values for me, particularly, is that issue of chronic unease. I have done everything I could today, but when I go home, you know, at 6, 7 o'clock at night, I say, yeah, but what more could I have done? And then thinking about that, go into work the next day and say, well, actually, I need to get on and do that. Now, the interesting thing about that is the mirror of unconscious incompetence and unconscious competence look very familiar and similar. You know, I always talk to people about car driving. You know, you start off knowing you need to drive a car and changing gear and putting your seatbelts on and all that. And then you go off and drive and you feel you're consciously, you know, unconsciously competent. And then one day you're driving towards, you know, going to a meeting, you're a little bit late, there's a bus ahead, you drive right next to it, you're looking for a place to overtake it, and it brakes, and all of a sudden you nearly crash into it, and you go, oh my God, you know. So you're in a place where you feel you're competent, but there's a wake-up call. And then the question is, and I think this is the interesting piece, and again it links into Flixborough and the conversations we have today, is that if you are unconsciously competent, you need to keep checking that. And the only way you're going to do that, I think, is by looking at issues and events that are taking place in other enterprises in your sector. Yeah. So what's happened there? Am I aware of other things going on in that sector? Can I learn from it? Then when you get to that place, to move on to say, so what does the Boeing 737 MAX failures tell me about how I should run my chemical plant? You know, those sorts of issues where you pull in cross-sector learning. And I think Dame Judith is very busy with actually doing something similar with the building sector and saying, well, look, you know, we've got this whole range of competence and expertise and very painful learning from incidents, and how can they apply to other sectors? And I think that's you know, a key issue. When I go to businesses that tell me they're unconsciously incompetent and really great at doing safety and in process safety, I always ask them one question, other than, well, what does Boeing 737 MAX tell you about your enterprise? I say, what would you do if I came and did a third-party audit of your site next week? And do you know what the majority of them said? Well, Ken, I'll go off and I'd go and check with so-and-so, and I'd go and check with Fred, and we would go and make sure things were in place. So when you came in, now, what you've got to remember is when a third-party audit comes in, it's a win-win. You don't do anything special. You just leave it as it is. And if the auditor comes in and finds things are as they should be and in great condition, round of applause, great win, success. However, if they come in and they find improvements, well, that's a win too, isn't it? Because that's an opportunity for you to really improve your business. And, you know, it's not a question you failed, it's a question there's something there that you can improve and therefore your business. But that difference between I'm going to let you come in and learn versus I'm going to make sure it's ready for you, I think underpins some of the really important cultural shifts that we've learned about as we've gone through Flixborough, as we've gone through Sebastian, as we've gone through Bhopal, as we've gone and Abhari for us, and right through to today. Yep.
No, thanks for that, Ken. I think there's a couple of issues that I want to pick up on, but I actually, first of all, just want to welcome Dame Judith Hackitt to the panel. Apologies for the challenges for you getting in. Judith, I hope you're well.
Yeah, I'm fine. Can you hear me?
Yes. Yep, we can. Good. I just want to come back and pick up on a couple of points that Ken just raised, and then I'm going to go to you, Judith, with a question. So there were two things that I think really stood out for me in what you were saying. One was around this idea of how we build competence and the whole, the journey from unconscious incompetence to conscious competence and the pathway all the way through. I think one of the things that stands out within Flixborough itself was the fact that there were engineers on the facility that did believe that they were competent to do the work they were doing and make the decisions they were making. I don't think at any point they thought, oh, gee, we don't know what we're doing here, but we'll go and do it anyway. I certainly don't think that's what they thought. So, we had that situation of making sure that we've got the right disciplines engaged and the subject matter experts engaged to ensure that we get the right outcomes. And I think that's, for me, a particularly strong learning out of Flixborough, one that perhaps we don't often really reflect on as much as, the management of change, the control buildings being in the middle of the process, those sorts of things. The other point that I want to pick up on as well that I loved is the need for curiosity in leaders. And I think that is incredibly important as a trait for people, to ask those questions and to sit there and say, how does the Boeing incident impact me when I'm running a chemical plant? Because there is actually direct linkages for what you can learn. And having that humility to be curious and to ask those questions, I think, is incredibly important. Judith, could you share with us how the Flixborough incident shaped your career?
Sure. I've said many times to people when I've been giving presentations on safety that it was quite a seminal moment for me. I was a student, like Ken. We are of the same era. At the end of my second year, doing exams in a subject that I thought was going to be really exciting and fun to get into that industry. And it was a real wake-up call for all of us to recognise, I think, that the industry we were about to join, we needed to grow up, as it were, and recognise the real importance of being responsible for safety. And that's something that's never left me, I guess.
Yeah, okay, thank you. Ramin, I might come to you. So obviously your awareness of Flixborough, as you said earlier, came later because, the US didn't really see a lot of this happen. So it came out of the book, the King book for you. What is the key takeaway that you've taken from that as you've learned more about it and explored that incident? What's the thing that sticks with you?
Yeah, one of the findings of the Court of Inquiry was that the dogleg pipe was designed by chemical engineers without mechanical engineering input or review. Apparently, Nitro's qualified mechanical engineer had left the company earlier that year, and his position was not backfilled. No mechanical engineering stress calculations were conducted to find out if the bellows and pipe assembly could withstand exert forces. So one of the takeaways for me is to always involve the right people in decisions that impact procedures and equipment. Incidentally, that is one of Chevron's tenets of operation, to always involve the right people in such decisions. And these tenets of operation were developed in the mid-90s by reviewing accidents and kind of come up with themes and how to prevent them. So so I find myself in this particular case at work always referring to that tenet of operation because of its relevance as a takeaway from Flixborough. Another takeaway is again, the Court of Inquiry report cites that there was a lot of pressure to restart operations after reactor 5 failed and they had to shut down. And it's amazing to think that in 3 days, they removed that reactor and came up with a custom bypass pipe design, the dogleg pipe, and had that installed, and they were up and running in 3 days. One can only imagine the pressure, and during periods of pressure, when you're trying to rush to get something done, that's where a lot of errors can happen, and overlooking some potential pitfalls, as was clearly the case here. And so that's another takeaway from me from looking back. And again, in terms of how that's learning has been incorporated, I'm glad to see that in Chevron we have this principle of operation that is there is always time to do it right. So at least in principle, we can come to the conclusion that others have seen what can happen when you try to get to complete something under pressure to get the unit back up and running very fast in a hurry.
Hello, Judith. Hello, Trish.
I think Trish is frozen.
The weather in Australia must be really cold today.
Yeah. I like that phrase though, Ramin. I've not heard that before. There's always time to do it right. I think we could discuss that at some length, and it would be good for other organisations to think like that. That pressure for production versus doing it safely. That's a really good way of encapsulating that sense of we have to get it right.
Yeah,
My apologies, my internet just dropped out. I'm back.
Yeah,
We were just discussing, Trish, there's always time to do it right that Ramin was talking about.
And I think it was interesting, Ramin, you mentioned the time frame that they managed to get that that spool piece up. And in fact, the engineering and the manufacturing, the fabrication work to make that spool piece as accurately as they did in that time frame was actually quite astounding. So in terms of the quality of the fabrication work was actually quite magnificent from that perspective. It just should not have been fabricated. So I think there's more the challenge there. Thank you. Robin, so from your perspective, what's the key takeaway for you?
Well, immediately I'd like to build on what Ramin said. I think, you know, the changes that were made, and I really think, you know, it's echoing it, the guys doing the maintenance work were really very good. It's a bit reading the report, it's a bit difficult to read. They're classed as engineers. They'd obviously had some really good training because they could do that directly. On the other hand, their theoretical training was really very limited. And I think one of the comments in the report is they were asked to do things they shouldn't have been asked to do. They were just given that job, they got on and did it, and nobody questioned, are you properly trained for that particular piece of work? And that it did read it. If you actually look at the not only the report, but there's some work carried out afterwards. The failure's quite complex, actually. Takes me a long time to work through what is happening here with the bellows, what's happening with the connecting piece. It was a complex failure, but the knowledge was there to do it, and it just wasn't. So I think your comment of make sure you involve the correct people, get the correct expertise, is absolutely key, and that's good. And also, perhaps we can come back to it later, the pressure to resume production. The other big take for me is the reactor that came out had a big crack. It's 3 meters long. I've never seen anything like that, fortunately. So, as I've said, I've had a lot of years in the chemical industry. It was a big crack. They went back into production. At that stage, they had not decided to look at any of the other reactors, and they didn't know why number 5 reactor had failed. So I think that's another thing that, you know, pushing back on and not asking the questions. I think it was a really, let's face it, it was a really low point for the chemical industry, certainly in the UK and Europe, that we'd actually got to that stage without thoroughly understanding what we were doing. We'd had a lot of development of technologies, scale, etc., all very quickly. And to be quite honest, the safety regime we were operating wasn't much different from the 30s and 40s. It hadn't moved. Now, fortunately, I think we did learn from that very much about questioning how things could go wrong, management of change, etc. But
Yep.
also, I think it went
Thanks for that,
wider.
Robin.
We did
Judith,
ask,
your key
Yep.
takeaway as a result.
Sorry? You still there, Trish?
we can hear you, Judith.
Everything's happening today. We've got a storm happening in Melbourne and I am losing all internet. I'm doing my very best to stay with you. Go on, Judith. What's that one key takeaway that stuck with you?
I think I would pick up on and link it to what Robin has just said, which is that the more you reflect on what happened at Flixborough and think about it in today's terms, we spend so much time looking at what happened, and it's patently obvious that in the case of Flixborough, that before the incident itself happened, people didn't have that sense of why has this happened already. So, you know, in the worst possible way, that crack in the reactor was a leading indicator that all was not well, and they didn't take any notice.
Yep. Yeah, so they missed that point to really understand what was going on. Okay, yeah. Thank you. Ramin, a question particularly for you. So you wrote a graphic novel called The Nylon Years, which actually talks about the history of the development of the chemical process into it, the Nipro facility, the Flixborough incident that then occurred. What really prompted you to write that in that particular style as well?
Yeah, it was in 2015. That year, I witnessed firsthand the aftermath of 2 fire incidents at the plant I was closely involved with. The team I was part of had developed the process and designed that plant. So those fire events with the injuries that occurred at the same during those fires left an indelible mark on me and prompted me to reread King's chapter on Flixborough that was so impactful to me as a younger engineer. And so the King's book was published in 1990, so about 16 years after the event. And so I think he had the perspective of time as a respected British chemical industry professional to look at all the facts, and he had put together a very meticulously laid out timeline, and which made that whole his narrative of Flixborough so compelling to me when I first read it. And so I decided to turn that into a story. I imagined that as told by fictionalized, dramatized set of events, but following exactly the same timeline of events as laid out in his book. And so that I could communicate that impactful chapter to me, to my other colleagues, especially in the US, who hadn't heard of the event. And why a graphic novel? Because visuals transcend barriers. My goal was to engage visual learners, ignite curiosity in younger engineers, honor the victims of the Flixborough disaster, and maybe prevent similar incidents.
Yep. Okay, thanks for that, Ramin. And I have a copy of it, and I've certainly spoken to a lot of people about it. And I believe we do have it available as a download from the Loss Prevention Bulletin website as well. So that is available for people to access, particularly if you want to look at a more visual medium to learn and to understand what could have occurred and what did occur in some of those things as well. So I think a question I've got now, and I'm going to pose this question to all of you, and it's a little bit of a controversial question, I think. So obviously Flixborough occurred at a time when our processes and our systems to a certain degree were a lot simpler than they are today. We've now got a world of increased complexity in what we're doing. We've got safety management systems, we've got better understanding of inherently safer design principles, we've got better control systems in place now, we've got our management of change, we've got all these sorts of things, but are we any safer? Could an incident like Flixborough happen again today? Ken, what are your thoughts on that?
Could an incident like that happen again today? The answer is yes. Do I think the chances of an incident happening again today, are those chances still as great as they were at the time we had Flixborough? I think the answer to that is no. And the reason I say that is that in the intervening 50 years, we've had a whole range of incidents that have occurred that have caused catastrophic damage to life, injury, environment, business, society. And the one thing I would say is that every time that's happened, we've gone in and we've learned stuff. I think the issue that we've got today is that we probably know enough now to never have an incident. And why do I say that? I think that's because when you look at the incidents that we have today in the chemicals and sector, the majority of, in fact, the vast majority of incidents occur due to things that have happened before, things that we've learnt about, and things that we've developed best practices to eliminate. And so I think the feeling for me here is that, yes, we are more complex. Yes, we have got more systems. Yes, we do know a lot more. And the question is are we doing that consistently? Are we doing that continually? Are we doing that comprehensively enough? And I think one of the key things for me was when I was recently leading the Coma Strategic Forum, when we said, well, what is it that we're trying to achieve? We're trying to achieve, a thriving, safe and sustainable sector with strong compliance, high standards, etc. And we said, well, what is the key challenge to delivering that? What is the really big challenge? And the answer was to make good practice into common practice. We've learned the lesson, we've had the incidents, we've learned the lessons, we've got the good practice that can address them, but actually we're not doing it as often as we should. So we know the things we should be doing, and we are not doing them consistently, continually, comprehensively enough. And I think for me, that's probably the biggest dilemma. I think critically within that is a role of leadership, creating the environment within which you have a culture, you have behaviours that encourages you to be curious, that encourages you to say, well, hey, there's a good practice over there, why don't we apply it? Why aren't we doing it here? And to, create an environment where we have very strong responses to weak signals, where people have concerns and that we address them. But I do come back to that. I do come back to the issue of, yes, those incidents can occur today. If we have one tomorrow, it will be, I would guess, 99.99% not new, with systems, procedures, observations, things that we could have done to prevent it, and we haven't done it. And I think part of that is to get out to people, many of which today who are listening on this webinar about what we're doing. So they will go back in and say, yeah, I can do that. But our biggest problem is that we spend so much time talking to the people who are interested. And the biggest challenge for me is to engage, connect, and start conversations with leaders who don't think they've got a problem or think it's somebody else's problem, or simply feel that somebody else, like the regulator, should tell them what to do, and then they might think about doing it if they can afford it.
Thanks for that, Ken. I think one of the things I'd like to reflect on in what you've said there is that we actually know how to solve these problems. And so, you know, Judith, I've often heard you say that there are no new accidents. Do you want to take that on?
Absolutely. I agree wholeheartedly with Ken that, you know, when you get down to the right level of analysis, there are common threads in every incident that we see, and the same things keep happening. And I agree that we could have another incident. What worries me about that long list of things that you suggested have moved us forward, I wouldn't argue that, of course, they have moved us forward in helping us to put barriers in place to prevent things happening, to control processes better. But what they've also done is created room for complacency. And I would imagine every single one of us has had conversations with someone in industry not that long ago where we said, but what if this were to happen? And the response you get is, that can't happen anymore. Really? Are you sure? How do you know that? You know that when anyone says to me that can't happen anymore because we've got systems in place to stop that happening, all that tells me is there is an inherent complacency there. They haven't really thought about it. And what worries me even more is if they are over-reliant on those preventive barriers, then the other side of the bow tie diagram has probably been neglected. Because if they don't think it can happen, why would you bother putting mitigation in place?
Yeah, good point. When I hear people say to me, you know, no, that can't happen, I try and turn that conversation around to, okay, just humour me in this. How could it happen? Because at least then we start to have a conversation about the barriers, and we can start to explore the barriers and how they may fail and how we may be able to detect it and how we can then ensure the integrity of them. So it's around changing the focus of that conversation, because but the hairs on the back of my neck stand up on end when someone says, no, that can't happen. Absolutely. Ramin, from the US perspective, I guess, so, you know, very different legislative landscape. What are your thoughts about, are we any safer? You know, can these sorts of things still happen today?
Since I don't work in an organizational safety capacity, I'm really not in a position to comment about effectiveness of safety management systems. As you may know, US facilities that meet certain size and volume of hazardous chemical inventory automatically fall under OSHA PSM, or Process Safety Management Standards, and which is there's a lot of management systems that go with that. That includes 14 different components ranging from an MOC system to a PHA system to training, but I'm sure somebody in our organization who's involved in safety could comment on how effective they are, but I really don't have the access to statistics to make that call. However, as an engineer, I can say that a lot of at least a couple of the key learnings that following Flixborough that were adopted by the industry have indeed made us safer. So most of the fatalities at Flixborough were from the vapor cloud explosion that destroyed the control room. Today, we use vapor cloud dispersion and blast radius models to ensure all buildings that would be impacted in such a scenario are constructed to appropriate blast resistance standards. On the prevention side, although inherently safer design has not been adopted to the extent that would prevent such a vapor cloud explosion, we are seeing developments that are headed in the right direction. More new generation of same petrochemical processes are being developed where you have more active and selective catalysts that translate to smaller reactor and separators with smaller hold-up volumes of the liquids in the system. And also in terms of the inherently safer designs, we're seeing equipment that is safer as well. Like one example is canned motor pumps, which are sealless pumps. So there is no risk of seal failure and loss of containment and hydrocarbon release, which has been the source of some other vapor cloud explosions, not necessarily, not of course what happened in Flixborough. So I think overall, from a better engineering, we are seeing advancements that have reduced both the likelihood of an incident, a release, and certainly the consequence in terms of destruction of occupied spaces.
Great, thanks, Ramin. Robin, what are your thoughts on this issue?
Well, if I look back to those early days in ICI, it was more dangerous at that time. I went to work on a plant that had a vessel failure about a year before I went onto it, and I was shift manager on a plant that had a fire. Not on my shift, I must say, but it was on the plant I was working for, so it was very close. We are a lot safer than that, but we'll only continue to be safer. We continue to apply all of that knowledge and experience. If we relax on that, it'll be a problem. I've got two areas I think that concern me. One, I think we've just identified earlier. All of us here worked for fairly big companies, and there were other people. Getting back to this competence, if it was mechanical engineering, there was somebody. I felt in ICI, and I know Ken and Judith, Ramin feel the same. Find somebody else with the right experience. We're probably now going into an area of change with new entrants, perhaps more SMEs. And how do people operate in those companies? How do they get the right expertise? Perhaps you can't afford in an SME to have all the expertise you need. How can you have it available? So I think that's an area of concern to make sure we can cover that one. The second one, maybe a bit controversial, is I think we've got to make sure that safety itself doesn't come too complicated. We deal with very complex systems, and I think HAZOP works because it just asks simple questions: more flow, less flow, and we can break down a complex system. So it helps me to understand a complex problem. If I've got a complex way or model of looking at a complex system, I don't I don't get there in the end. So I think we've got to avoid it being overcomplicated, and secondly, make sure it doesn't become the preserve of professionals. It's got to be something that everybody takes a part in, I quite often say to people, not only in the chemical industry, but in other areas as well, the risk assessment is very good, but does the guy doing the job know it? It's what's in the risk assessment is good as long as it's in people's head. If it's away in the filing cabinet, it's not so useful. It's got to be there and active. So let's try and find ways of ensuring it doesn't become overcomplicated and too difficult to apply.
Yeah, I think that's a really good point. We can get caught up in the busyness of safety rather than helping businesses achieve that safety. And there's a lot of research, a lot of activity in that particular space, and we need to be careful that I think we don't fall into the trap of that. I want to pick up on something you raised about, smaller organisations may not have those subject matter experts available. And I think we are seeing a lot more engineers now, even graduates, going into companies where they might be the only engineer in the organisation or at the facility, certainly. What do you think we can all as a profession do to help support the development of those people that don't have the luxury of, all of us have worked in large corporates. I entered as a graduate engineer into Mobil Oil. there was a structure of engineering around us. There were standards. There were people I could ask and learn from. You know, Judith had that. Ken had that. Robin had it. Ramin, we've all had that. There's a lot of engineers now that don't. Judith, your thoughts on how we can perhaps better support the profession in this space?
I think this is a really important topic for me, and one that the professions themselves need to reflect on, in my view, that as the world changes and our membership is much less about people from large corporates, and many more of our members are from SMEs, is the work we do on CPD, are the courses that we run right for those people, and not just in terms of is it targeted at them, but is it targeted at the sorts of processes that they are now engaged with? You know, the other thing we've all got in common is a hydrocarbon background, for goodness sake. You know, this is, and we are moving into a very different era of molecular engineering, and it needs a rethink on how we turn our minds and our expertise to the new risks in a way that will be relevant and helpful to the younger engineers in our profession, who are probably working in very different industries.
Yeah. Thank you. Ken, any thoughts on that from your perspective?
Well, I think firstly, from a profession point of view, I think the sort of thing that we need to reflect on and work on is, what do we need to do in terms of changing, developing, building that level of knowledge, awareness, and curiosity, and in the area of managing hazards and safety. And I think it's good to see that, you know, within the chemical engineering context, process safety is now an integral part of a graduate course. And it certainly is something that when, for example, the Institution of Chemical Engineers goes and looks at an approved course, it checks out quite thoroughly. And the conversations I've been on a few have been very, very constructive, quite keen to understand what might be needed. Again, the issue there often it's getting within the university course the industrial context rather than just the intellectual content, so that real examples can be put in front of students so they understand and can address them. And so that bit about, you know, university departments linking with industry and making that connection, so that as students go through them, not only do they get the context and the intellectual piece, but they can see the application, and that opens their minds and maybe helps them focus as they go on. I think, you know, there are future challenges for us within the Institution of Chemical Engineers and other engineering professions, of course, clearly with AI and cyber and all the rest of the 9 yards. I think your reflection about needing to transfer knowledge and know-how, I think, is absolutely crucial. I think one of the things that I think I picked up from the offshore industry is that if you look at the level of safety in the offshore sector, I think the traditional oil and gas activities have a level of safety that is 4 times better than the other sectors that are currently operating in the offshore. And I think that just demonstrates that, you know, we've got to, if you like, take that learning and awareness that we've had and developed through very, very, very painful and consequential incidents and get them transferred where it's appropriate, where it's applicable into these new applications. I think the other worry that I'm concerned about, particularly as we move through this, and a lot of it, of course, driven by net zero, the energy transition, etc., decarbonisation, is that there are assets out there where the focus is moving on from them. They appear to some as being sunset industries where, you know, investing and keeping them going, well, actually, we really want to put that investment in other places. And that can lead to, you know, the focus going away from areas where we know there are risks and we know what we need to do them, but actually we're not getting either the resources or the investment to make sure that that's maintained. So I think there's a challenge there, but I think the profession is having a go at process safety, and I do see that within the department. I think that really helps. But then, of course, for students going in and operating within SMEs, creating that network and forum, particularly, and the IChemE can do something about that, creating that network and forum so folk can develop their skills, know that there are skills that they need, go to their bosses and say, hey, I think I need to know about this. Well, and in areas where, you know, people are struggling, we've now got the forum where people can put their hands up and say, hey, I think I've got a problem here, can you help? And creating that opportunity for people to share concerns, which will help them to hopefully address them better. I think within the whole context of this, though, it's critical that the leaders of industry in SMEs, as well as in big enterprises, understand the risks that they manage, understand how they might manage them better, and then can demonstrate that they've managed them to as safe as reasonably practical. Those three questions are things which we need to get into every leader's head who is operating in a major hazard space. And I don't think we're there yet, and I think that's a big challenge.
Yeah, thanks for that, Ken. Ramin, your thoughts on this? You're muted.
Trish, I think you're correctly identifying a gap in early career development of engineers who lack, if you will, the large corporation sponsorship or for developing that safety competency through in-house trainings and the like. I mentioned that there is some training required for those operating in the US. They call PSM plants, you know, that are under the process safety management standards. However, those trainings are very operator focused, and they're not really, I would say, for engineers. Of course, engineers can benefit from it, but it's doesn't establish a very in-depth understanding about, you know, like some of the things we talked about, vapor cloud explosion phenomena, and so many things that involve some engineering calculation and understanding in them. So I think a case can be made that organizations such as IChemE and IChemE can play a role in defining what that engineering safety education would look like. Maybe building up on what some academic programs already have, but even expanding them with input from industry, and then just provide the online modules to obtain those trainings and get a certification, kind of analogous to the PE certification for registered professional engineers in the US, but for a safety trained engineer. And so at least there is that minimum standard of a safety competency that engineers need to complete, so it's that can be provided and checked on. And with the normal, just like a PE certification, you need to maintain your certification. You have to go through some kind of a continuing education every year. Something like that can be established for a safety certification for engineers.
Okay. Thanks for that. So I guess just for a bit of information of what we've got out there, IChemE's Major Hazards Committee has done some work on looking at competence at all stages in an engineer's life cycle in what they need to know about process safety. So there's a great piece of work in that particular space. That's been a really good piece of work. The Safety and Loss Prevention Special Interest Group do a lot of engagement with universities and have some resources and materials available for teaching in universities. The Safety Centre that I lead, we've created a lot of resources for universities as well. And obviously IChemE has just recently, sort of relaunched with substantially its professional process safety engineer registration as well. So that recognised certification that you talked about there, Ramin. I think just on that, we've had one question come in from the audience. So when I talk to young chemical engineers, quite a lot have not heard of Flixborough. Should Flixborough and other key major accidents be a mandatory part of ChemEng courses? And if it should, what are the key lessons students should learn? Just as a highlight in sort of 3 sentences. What do we think about the embedding of some of these lessons? Who wants to have a go at that question?
Yeah,
Certainly not. Robin, you go first.
Well, certainly, I believe learning from the past is really important, and the incidents of the type we've talked about are the best ways to get that message across. You can incorporate the technical element, but it also brings in the fact that these are real and they affect people's lives. And we've got to cover that. So yeah, they need to be incorporated. Flixborough, I think, has still got a part to play. Perhaps there are others that could come in as well. But it does encompass so many different types of areas for improvement, from the control of change, as we said, siting of control rooms, understanding of technology. All of those need to be brought in and covered. But also, perhaps it can say, this is the time when things changed. And it was. This is the time when process safety really started to spread, perhaps from just 1 or 2 companies to being across the whole of industry. And that remains important. We've got to work together to ensure that we can develop the best systems.
Thanks, Robin. Judith?
I think this brings me back to my favourite subject of why versus what, right? So a kind of collection of stories of incidents that have happened in the past is a really valuable resource. It is more valuable if that is focused on not just what happened, but why it happened and the relevance of the why to the present day, because otherwise you will get a kind of, well, that's interesting, but then it's back into, but that can't happen anymore because we've changed. And we have changed, but the fundamental principles, the whys of what went wrong, management of change, pressure for production, all of those things are still there. So what matters to me is not just that we collate that information about the past, but that we collate it in the right way and produce it in a form that is sparks debate rather than is just there for information, because it's that richness of the debate that says, so what can I learn from this? What do I need to know? What do I need to understand? The whole point about, look at this picture from the past, look where the control room was. We don't do that anymore. Do you know why? If you actually do it in that kind of interactive way, the lessons start to embed in people rather than them just unquestioningly hearing the story and then thinking we've moved on.
Thank you. We've had a couple of questions come in around, we've talked about, we've had so many advances in systems and processes and technologies, and one of the advances that we've got happening at the moment is artificial intelligence. What are your thoughts on how could artificial intelligence potentially help us identify, risk assess better, get to the point where we actually understand and are able to prevent incidents happening in the future? Anyone want to have a go at that question? That's a big question. I've combined quite a few that have been coming in, but any thoughts on the use of AI in terms of better understanding our risk?
Well, I think AI is, from what I've seen and what I understand of it, has got the capability to go in and look at data, look at documents, assess them and come out with points which you might want to think about and learn about and do. And I do believe there's an opportunity there for us to get even more insight out of some incidents as a result of it. I think it's probably also a good idea to actually also capable of picking out even deeper structural underpinning lessons that we could pick up. The danger for me always, though, with new insights and new things is that because we have run through technological challenge and change, which has been groundbreaking, particularly. And I always remember one of the jobs I had at one stage was deciding how you ran a refinery, which was, got all these crudes that we could run, we could all the products we could make, we've got all this complex processing systems that we could do, and how could we make the most money of doing that? And we had a computer program, and we used to load data in, and it would chunk away for about 48 hours, and it would come out with an answer. And it was really quite a big effort. And so a lot of what you did in that situation was to do a lot of thinking before you got the computer to do what it was doing as a result of that. But later on, of course, we had operational transformation, and IT systems computers no longer became as big as a 5-story block. They became something that was on your desk and now is in your iPhone. And what happened then was that people would come along to me and say, Ken, we've decided we're going to run the refinery next week with this crude from Libya, that crude from the Sahara, that one from Venezuela, and we're going to mix them all together and do that. I said, so why are we doing this? Well, it makes the most money, Ken. All right, yeah, okay. So why? Well, actually, it's run 1,762, and it gives us an extra 10 cents than run 7,225. And I would say, why? And the answer was, well, that's what the computer says. And the issue I am concerned with as we move through with AI is I think there is the potential there for huge and valuable learning. But the insight within it sometimes is with AI that you don't get the reason why, and that's a point Judith, of course, been emphasizing, the why this is something that you should do. The other thing about AI is structurally it has embedded bias, which we don't recognize. And there's lots of computing examples where we find that AI is pretty good in this space, but it's not very good in, in other spaces, because actually the background of the people who put this all together have a particular inherent bias, and that impacts on the result going out. So I think with AI, as we move it forward, we've got substantial opportunities, but also the potential for substantial risks. And I think it goes back to the transparency of what AI is telling us, and can we get our head around that?
Thanks, Ken. Yes, Robin, what are your thoughts on AI in HAZOP? Have you had a chance to reflect on any of that sort of aspect at this stage?
I'm not actively involved in that. I do believe it's got the opportunity to help in there, particularly perhaps in picking up the kind of incidents that cross from one boundary to another. HAZOP is very good when you are looking at what you can see on one line diagram. It actually doesn't, and there have been cases where something on another part of the plant has transmitted through, and they can be quite complex to pick up. So I think it's got a real potential to help in those situations. I suppose perhaps it's echoing the point of Ken. I said I like things to be simple, and if I don't quite understand how the AI is working, I'm probably a bit skeptical at that stage. So I'd want to be sure I've got a better understanding of how it's working before I can trust it. Perhaps that would not be possible. I don't know. We need to think about that one.
Cool, thanks. I'm trying to sort of bring some questions together here because we've got heaps of questions coming in from the audience, which is fantastic.
That's good.
I want to move to focusing on management of change systems for a moment, and I'm going to sort of throw a few different questions at you because there's been a bit of a discussion going on in the questions pane on this. So someone's actually raised the question of, we've got all these management of change systems now, we've developed them, we have all the processes, but we still have a constant tension between operations and the management of change process. We still see MOCs fail. Why don't they work effectively? And do we have the right guidance for it yet? Ramin, what's your perspective on management of change in that space? Do you think we've got the right guidance? Why do you think that we see failure of the systems?
I think with a lot of these management systems, there is a tendency to rely on the paperwork, to just go through a checklist and just check them off, like I've seen with PSSR checklists, and that's not the best way to go through the spirit of the system. I mean, you may just generate the paperwork to show that it's done, but to understand truly understand what you're really checking off on also matters. So I think there is, again, falling back to the question about why these case histories matter. I think having a kind of a safety culture where the people, the operations understands the story behind each of those boxes you're checking off will go a long way in meeting the spirit of that management system. For example, we have lockout tagout, the LOTO system. There are actual stories about what happens if you don't follow the lockout tagout and what can go wrong. Anything from Piper Alpha to Phillips Houston petrochemical plant explosion. They're all cases where a LOTO was not followed or had deficiencies in it. And so checking a box that says, yes, this is in place, this lock is in place, means something. So I think once that is established, then people don't go down the checklist blindly checking off things. They would be more likely to truly go and explore, to check to see whether that's truly there, as opposed to say, yeah, I think it's there. So that's my thought about these safety systems, is that they'll go a longer way if we kind of communicate the story behind it. So the case histories that support that system.
Yeah. Thanks, Ramin. Judith, do you have any thoughts on that MOC question?
Yeah, I do, and I think it follows on from what Ramin said, which is this, to me, there's still this healthy tension or unhealthy tension between the extent to which you prescribe and the extent to which management of change systems are there to drive people to think. And I absolutely recognise that, if you go too far down that prescriptive route, providing people with a comprehensive checklist kind of makes you feel good because you think you've got everything covered, but actually your brain's turned off and you've just ticked the boxes and you haven't really thought about the consequences. So for me, there's a really difficult question here about the balance between how much we prescribe, how much we put this into paperwork, and how much we drive people to think about the right issues. And I suspect that some of that needs to be about asking questions and asking them to explain themselves rather than simply giving them a box to tick.
I totally agree with what Judith says. It's prompting a discussion. And this is an example. This was really probably quite an amazing example I had. It wasn't in the area of management change, it was in the area of operating instructions for a plant. And what we found was that many of the failures that we were having on the plant was because people weren't following operating instructions. And what was that about? And it goes to a related issue, which is, why are we doing what we're doing? So what we did was, and it had an absolutely fundamental change on the operations. We had our operating instructions, which was turn double fluffy woof-off valve left at this point. And then, you know, open expander joint Y and stuff like that. And what we then did was, against each of those statements, was to say, we're doing that because if we don't, the temperature goes up and then we'll get overheating over here and a failure. We open up that because actually that opens up the relief valve so that you can then, if then anything happens, we're protected. So at each step in the way, we had the why of the what we were doing. Now, what then happened is that led to a transformational change in terms of people applying the operating instructions, but it also had a fundamental change in the sense that it then opened up a dialogue, because then the operator would say, I think there's a better way of not having that overheating, not by operating doubly fluffy valve 1, but actually we could do 7 and 3 together, and that will be much more effective, and it would also protect you from this as well. So it opened up a discussion, which then led to a change in the operating instructions. And my experience of doing that was transformational in terms of the safe operations of the plant. And I think you could apply that to the management of change, which is, we're doing this. Why we're doing this? Because actually we're doing this because if we don't do it, this will happen. Or because if we do it, that will happen. And that will then open up a discussion with, well, actually, I know a better way of doing that. Or we could do this instead, and that might be even better. And then that discussion gets prompted and it becomes a live document rather than a passive tick box.
Thanks, Ken. I think flowing on from that question, it starts off with a comment, but then there is a question here. So Flixborough was a formative event for PSM and could only be so impactful because of a professional and transparent investigation sponsored by the UK government. Unfortunately, there have been incidents in other countries in recent years where nothing is offered up to the wider industry, either because of lack of state investigation or because the findings were retained as proprietary. Do any of you have a view on how we can progress through and get better investigations and influence the openness in investigations so that we can get the learnings out of it, get to the real whys and share those? Anybody? Judith?
The topic I've been involved in discussion about many times, you know, so it's come across IChemE's desk in the past as a, do we need a chemical safety board in the UK, like you have in the US? First and foremost, I think that it's really important that we do have open investigation. I actually think it's become much more difficult to have those sort of in-depth investigations, and some of that is about societal change, actually, that people want quick answers. They don't want to take the time to do the real in-depth review that is going to get to the real root cause. So people want to get on, find something to fix and move on. So driving for root cause analysis is hugely important. That's the first thing. The second thing is we've got to put the lawyers in the right place, because hundreds and hundreds of investigations into incidents get tied up in legal privilege. And as you heard me say 2 weeks ago, Trish, lawyers are there to give advice. They cannot be allowed to control the process. We are the professionals. It is our ethical and moral duty to tell the story, to listen to their advice, but then to also listen to our own hearts and minds about what we do and what we say and what we share. That's my starter for 10.
Thanks for that, Judith. Robin, any thoughts from you?
Yeah, obviously, investigating incidents such as this are important. Perhaps you've got to balance this to, is it better to have the big investigations or lots of little ones? And perhaps in a way, lots of little ones also have their value. Every company making sure it's looking carefully about what's happening in its operations and learning from those. That particular one. Perhaps another thought coming in for a different direction is look outside as well. Perhaps we're encouraging other industries to look at the experience of the process industries. If I would take an example, I think Ken's already commented on Boeing. Boeing had an extremely good safety record, probably perhaps even better than Airbus. And then they designed a plane where the key requirement was you mustn't actually require the pilots to have any more training. They incorporated elements, and the pilots didn't know about those elements. So when they failed, they went wrong. And, you know, it was had those 2 serious crashes. And to me, that was kind of a change right through the whole approach of Boeing of perhaps not giving safety the priority which it had in the past. So we can learn by looking at other industries and how they responded to incidents as well.
Yeah, I think that's really important. So, for example, actually tomorrow in Melbourne, I'm delivering a keynote at a conference and I'm talking about Boeing, but I'm talking about it from a process safety perspective to the gas industry. So there are definitely learnings there. I've done a lot of presentations on theme park related incidents, on banking misconduct, because there is actually these wonderful transferable learnings. And just on that, I've got another follow-up question here or comment as well. Someone said that whenever they've delivered in-house training on MOC, they've always cited Flixborough as one of the key learning incidents, but always used some other examples which sometimes may be contentious because they're from other industries. Things like Grenfell, Nimrod, MR2, the Concorde, smart motorways, all of which have MOC as contributing factors. There are clearly many more. What can be done to ensure the non-hazardous, non-chemical sectors can properly learn from such incidents? Any thoughts? I mean, Ken, from the health and safety executive perspective?
Yeah, you know, it's one of the things that has struck me throughout my career is that, you know, sometimes we just sit in our box and, you know, think about what goes on, what touches us. Occasionally we look over our shoulder and maybe look at another location in our same company and try and learn from them. But you know, that's dismissive. You know the French would always do that, wouldn't they? So it's not applicable to us. And you know we have little boxes, and then of course you know the boxes that say, well, actually, you know, we're the oil industry and we know a heck of a lot. You know, we're absolutely there. But what does the chemical, you know, the chemical guys, the inorganic chemistry people know about this? You know, and I think that's part of the issue, that we have to understand that the underlying issues that underpin delivering in the area of safety and also in the area of major hazards is not unique to any particular sector. There is generic learning. I mean, I always come back to these 3 questions. What are my risks? Do I know what my risks are? Do I know how to manage them? And have I, and can I demonstrate that I've got those risks managed down to a reasonable level? You know, and having got that, everything else follows. Getting the context, getting the leadership actually wanting to know those, that having those questions in their mind and asking them of their organization is what makes the difference. Because sometimes what we can get, you know, a piece of information or a piece of learning, but it actually doesn't get applied. Why? Because it's not seen as important. So I think there are 2 issues here. One is making sure that we surface the learnings that we need, but I think often the bigger point is how do we create the environment when that learning can then get applied. So I think there are two aspects to this question. I don't know if that helps.
No, I think that's good. Thanks. Anyone else want to weigh in on that one? Judith?
Yes, because for me this is a really important issue for IChemE, and I think, you know, when all's said and done, you know, and we've said we must not become complacent, and I absolutely agree with that. This profession has done a fantastic job over the last 50 years of building a body of knowledge around process safety and risk and hazard management in our industry, and we have moved so far. Still no room for complacency, but we have not done a good job of sharing it. I think we've done a really poor job of sharing with other engineering professions that knowledge and making it relevant to them. Think about some of the other examples you've just used. You'd never design a smart motorway if you knew enough about human factors, because you'd think
True.
about how people are going to behave.
Yep.
In the case of Grenfell, what went wrong in Grenfell? People didn't look at the buildings as systems. Stuff that's fundamental to us, we have failed to share with other people.
Yep. Okay. A question here, and this all ties in together quite nicely. I often see a problem in the nascent hydrogen industry, as a lot of facilities are being developed that handle quantities below any regulatory threshold, but can, if released, lead to serious accident. Additionally, a lot of projects are being developed by companies without any background in major hazards, who are not aware of process safety assessments or process safety frameworks. They tend to rely on PHAs carried out by vendors, and they don't have the competency to understand them. So the question here is a challenge back to institutions like IChemE and AICHE. How do we help these new industries navigate this space without them having to suffer their own catastrophic incidents that also potentially will stifle new project development, or without stifling that project development as well, though? So not being too onerous, but enough. Any thoughts from anybody on that?
Well, clearly one of the important factors in that is ensuring that there is a regulatory framework that covers new applications, new things, which ensures that actually those things are actually put on the agenda. So clearly there is something about the regulatory framework in terms of helping that to happen. And I think clearly as enterprise and outlook and technology changes, you know, you've got to look at how do we ensure that there's a framework there that's going to be able to deliver that. I think the other thing which we as a profession can look at is how can we create within the minds of the people who are doing it the fact that actually, hey, hold on, you do realize that what we're about to do can create that hazard, and we really need to do something about it. Otherwise, somebody's going to get killed. And I think sometimes what we can get, an enterprise can get probably overridingly driven by is there's a whole load of money here to be made, let's go off and get it. Or there's a whole thing around something that will give us a lot of background, like it's just net zero and it just delivers zero emissions, so we don't need to worry about the safety of it. We need to get that into a balanced discussion, and it requires people to know that they have to put their hand up and then create an environment where they can, so that those messages get heard. And I think that's probably one of the big issues. Again, and I see it coming back to this issue of leadership. So I have to apologize. I always see, if you are leading an enterprise, then you need to have your ears open to what people are telling you. You need strong responses to weak signals. And if you're getting a signal that is not conducive to what you're trying to achieve, you should listen to it even more, because it might be important.
Yep.
I think it's a very, I think it's a very good question. And perhaps the key thing, we should try and make contact with the person who asked it and say, what is the need there? I think Ken said regulation. That if you're fast-moving technology, regulation doesn't move quickly. And perhaps we should be finding other ways. And as an institution, we should be trying to make more contact with people in those areas and find out, you know, what problems do they face and how can we help them? I think rather than saying this is what you should be doing, say, well, what problems do you have and how can we help in that area? Perhaps it could start a dialogue from today.
Yeah, good suggestion, Robin. I think, you know, instead of going in with the we've got all the answers for you, it's is there anything we can help with? Question more. Yeah.
It's also I think, Trish, and we mustn't lose sight of this, it's a strong argument for outcomes-based regulation. Because Robin is right, if you live in a world of prescriptive regulation, it's hard for the regulator and the regulatory framework to keep pace with fast-moving technologies.
Yes.
If you live in a world where your regulation is very much outcomes-driven, same principles apply, whatever the technology.
Yeah. Okay. We've had a question around how do we better embed inherently safer design in our organisations? Because obviously we learnt a lot about inherently safer design out of Flixborough as well. And, you know, ICI was leading in this development area back in the 60s and 70s, and the concepts, and we still have those concepts, but they so often don't end up being embedded in projects because we don't try to do it at the concept select stage. We try to do it further down the path when we've lost the opportunity to put it in inherently. And even then, if we do get it in inherently, we go through the value engineering phase of a project and strip it out. So, you know, what are our thoughts on how could we get better inherently safer design principles embedded in industry? Ramin?
Yes, you're absolutely right, Trish. There is definitely a place in the project that is too late to change. With the scope of a design has been defined, and then the tendency then is to address the safety risks with just layers of protection analysis and putting in the safety layer, SIL 1, SIL 2, whatever layers of protection that you have. And so I do believe that there should be in the process development stage an appreciation when there is a choice between process A, process B, process C, to consider putting more weight in the inherently safer version. And as you are scaling up, consider those, I guess it's the 5 principles of inherently safer design, to substitute, reduce, all of that, to make sure that we are that design is being advanced. I do think, however, that sometimes the inherently safer process design is indeed the lower capital cost, just simply because it's simpler. You don't rely on instrumentation to safeguard. You're simply, due to the chemistry of the process, you know, are in a situation that you don't need to add certain protections. You're just safer to go with. Yeah, I think there is, again, I always fall in the case histories to kind of consider various processes that were considered out there and to kind of review to see which is the more profitable and commercial technology that has kind of stood the test of time. And I think often we do find that those are the inherently safer designs that have lasted. You can look at, for example, some technologies for producing acetaldehyde. There used to be a mercury-based technology for that using acetylene. That has no longer being practiced, just because it was led to a lot of hazardous effluents and the like. And what we are the processes that are practiced today are looking at the alternatives are indeed the ones that were more inherently safe. So I think that kind of supports the fact that that a strong case can be made that is worth considering that before considering all the options before deciding your final investment decision on which plant to build.
Okay. Anyone else? Robin?
Yeah, sorry, excuse me. It's going to be a balance, isn't it, in the end? Because we want safer plants, but it also has to take account of the environmental aspects, what materials are being transported, the storage, etc. And all of those can be better solved. Probably it's not chemical engineers, it's chemists who can make the biggest input by when they're at the very early stages, and we've got to encourage that. And economics will become a part of it. The super inherently safe plant, which isn't going to be economic to build, is not worthwhile. So we've got to balance all of those. I think the only other thing I'd like to add is, let's not forget the simple little bits of inherent safety as well, such as if you've got a critical orifice that's restricting flow, don't have it just as a little plate that's got to be put in, have it as a piece of pipe. A simple plate you can leave out. A piece of pipe is more likely to be there. So it can. The biggest inputs are at the early stages. There are opportunities to incorporate simple elements of inherent safety further down the line, and they're worthwhile as well.
I think my additional comment on this, Trish, would be that if we were to do one thing and one thing only, it would be to look at projects on a life cycle basis rather than an initial cost basis. And I think that would drive us to better decision making about inherently safer plant, which is simpler. You know, doesn't go the risks of it going wrong, all of the things that you don't have to maintain because they're not there. If we actually shifted to looking at projects and justifying them on a life cycle cost rather than initial capital cost, it would actually make a big difference.
Yeah, absolutely. Ken, anything to add?
Yeah, I totally agree with that, and I think one of the things I've always struggled with is how do you get the issue inherent safety onto the agenda, because often you're midway through doing something when you get involved and you see that question, you know, coming up. We could have done something completely different. And for me, I think that's a journey that we've still got a lot to do, which is, I think Dame Judith's right about the systems approach and the life cycle bit and getting that focus. But my experience is at the scouting phase, where you're looking at all the options, risk management isn't at the top of the agenda. It's not as much part of that discussion as it needs to be. The focus is on other issues, and I think we've always got that part where it used to be that we spotted a safety issue just as we were about to start the plant up, and we've learned to go further up that chain to get in at the design phase and resolve those issues later when it's just a piece of rubbing on a drawing and putting something else in. But I think we've still got to move it still further back up the project development phase to actually do a much better job in assessing risk, and as Judith said, in terms of life cycle at the point where we're actually defining the concept we want to move forward.
Okay. Go on, Robin.
Can we bring a point we perhaps touched on? I perhaps haven't discussed in a lot of detail. We've talked a lot about managing to change. That's important. Have we talked enough about safety culture and the role of senior management and boards, etc., incompetence. I think that's overall important. Okay, Boeing was an example, but we need to think about what is the approach to safety overall. Okay, perhaps not so easy in Flixborough itself, but if we look at things like the Deepwater Horizon, in Turney, I had to look at some of the costs of that. They were faced with a real problem. It was $1 billion a day of keeping that rig there. And if there's $1 billion a day, you seriously want to stop that cost. In actual fact, the inquiry identified a number of failures where there were safety options. In the end, it cost BP $70 billion. The cost of 70,000 times the cost of what they were spending each day. So we've got to try and get that approach across. And I don't know if other people have, perhaps it's once again outside our normal area of we're discussing. In 2006, a Nimrod plane failed over Afghanistan. That wasn't enemy action. It was a process safety accident happening inside an aeroplane. And if you look at it, there was an extremely good report into that. And the conclusion was the safety culture. I don't know if people have heard this one before from Hatton Cave. You need a reporting culture, a just culture, balancing no blame and appropriate responsibility where it is, flexible culture that can respond to change. A learning culture, and perhaps coming back to what we had at the beginning, a questioning culture, always saying why, what could go wrong. Yeah. Sorry, it's a bit of a lecture, but I really believe that's one we've really got to get across the whole of our industry. And that particular report, I think, is a very good one in that respect.
I think that's a really important issue, Robin. And, you know, at the end of the day, we actually need good leadership in process safety in our industries. And that leadership needs to drive positive culture. And certainly the culture elements you referenced, they're aligned with the work that James Reason did on a fair and just culture, which I think still really does stand the test of time. It's certainly an area that I talk a lot about. In fact, you know, this week I was delivering process safety leadership and culture training course to a company, and I'll be back in their city in July doing it again for another cohort for them. That, you know, companies are really starting to become aware of this culture aspect, but I still think there is some significant gaps, because to a certain extent, we're still preaching to the converted because they know they need to understand it. They know they need to get that information. From my perspective, you know, we're preaching to the choir. How do we get a bigger choir? How do we get more people in there that actually want to hear the message, that want to learn from it, and that want to actually take that culture journey, realizing that process safety culture and what's needed to deal with the process safety culture is not exactly the same as a safety culture, because we're dealing with things that are a bit harder to see at times, and the triggering event may be years before the actual incident occurs. Anybody want to weigh in on that idea? Ramin, you're nodding your head there furiously. Yep.
Yeah.
And I'll go to Ramin, then I'll come back to you, Judith.
I'll go really quickly on this one, because I think Flixborough narrative kind of touches on that. The reason I like Flixborough as a case study is because in the accident investigation, the timeline does not start with just simply okay, a reactor failed for unknown reasons and it was replaced, and with this dogleg pipe, and then later that failed. It actually, one can start with the decisions that went into the history of that plant, and they all played a role, like the fact that the decision was made to turn the agitators off. That introduced certain performance issues that were not appreciated at the time. But we know now that there was again, this is in the King's analysis of the event, that introduced this pool of water in one of the reactors that remained unagitated throughout the history of the plant, following that first decision in November of '73 to turn the agitators off. So yeah. So I think appreciating that that sometimes our tools for evaluating the consequences of a change sometimes may not be adequate to measure every consequence of that. Like in this case, the cyclohexane oxidation performance did not drop because the air that was bubbled in created enough of a turbulence that agitation was not needed. However, that did not capture what would happen during the transient periods when there was no air being ejected and there was water settling. So I think that's something that I guess is key here, is to kind of look for those hidden signals that sometimes we miss because we just don't have the tools for it, and just know that that exists there.
Thanks, Ramin. Judith?
I agree with that, and I think that one area where that is really true, and where we probably aren't as good at management of change as we need to be, is when it comes to organisational change. We're pretty good at reviewing the physical. We're not as good, and it happens a lot in all industries these days where we make organisational change. And the Nimrod example is a perfect example of that, because what Charles Haddon Cave uncovered there was an organisational structure where assumptions were made about who was responsible for what, and there was no clarity in the system at all about who was responsible for what. And I suspect, in fact, I know that that is far more widespread today than ever, in that we keep changing our organisations and we don't always stop to ensure that those roles and responsibilities and the governance process is as clear as it needs to be.
And I think there's also now, we're getting a greater understanding, but we still miss it a lot, is the creeping change. So the change that just happens through natural degradation of systems, that we're still not, we're starting to become more aware of it, but I don't think we're very good at managing it overall. We're almost at the end of the allotted time. I think this has been a great conversation. We've had a lot of questions come in. We've had hundreds of people on the call, which has also been fantastic. I'm just going to do a very quick summary of sort of some of the key elements that I heard in the conversation that we've had, and then I'll give you all a chance to share any last final thoughts you'd like to add. I think for me, some of the things that stood out is around leaders being curious and asking questions and exploring things, around competency and making sure that we involve the right people in the tasks that need to be done. About focusing on the why, not just the what, I think was another key one that came through for me. You know, understanding if we're asked to do a task that we're actually not competent for, or that we're not yet consciously competent in, that we actually have the courage to say, that's not in my scope, I need help, rather than just assuming we can do it. Process safety in chemical engineering courses, and I would actually broaden that out to, I think process safety needs to be in engineering courses. As a mechanical engineer, I would like to see better process safety in all sorts of disciplines of engineering, because I think it's important for everybody to have that understanding. Strong responses to weak signals was a comment that Ken made that I absolutely loved that comment, Ken. Organisational change, plant change, and creeping change. And I think for me, they've been some of the big key topics that have come out of this conversation we've had that I think has been really, really rich. As I said, I'm going to ask you all if there's any just final comment from you all. Ken, what's your final parting words for us today?
To my mind, leaders make a difference, and sometimes it's a bit unclear about what leadership is, but managers are really great at moving between A and B. Leaders decide what B is. Mobilize people, engage people, get them excited, help to get the support in place to deliver it, and then create conditions within which people who are really good at doing that change get supported to do it. and we are all leaders, and we can all make a really significant difference. And my key message to everybody today is you can make a really substantial difference to the safety of this world if you do a lot of the things that you've heard of today. Take that back to the workplace. It will make a difference. You will make a difference, and we will all be safer.
Thanks, Ken. Ramin? You're muted.
Sorry about that. As a final comment, I'd like to just emphasize something we kind of was implied here, but we didn't really, I guess, explicitly mention it, which was the whole notion of psychological safety within a healthy safety culture. In the graphic novel I wrote, one of the, I guess, the key moments in the story is when the operator who was who thought that the dog leg pipe was being installed without enough time to review. It's what we talked about, doing the proper mechanical reviews and investigating the root cause. Through his girlfriend, he started to type a letter to the plant manager to express those thoughts and try to have him slow down until this was completed. But his own insecurity, the fact that nobody was going to listen to him anyways, prevented him from doing that. Essentially, that's a case of he did not feel psychologically secure about communicating that. Now, I think most organizations are encouraged, they have instituted stop work provisions, which is very new and revolutionary, I would say, for even within the past 10 years, but those are in place. But I think ultimately having that psychological safety, that people feel free to speak up when they see something is unsafe, is key part of a healthy safety culture.
Thanks, Ramin. Robin.
And Trish, I just want to thank you for this excellent panel discussion, and for you and Tracy and everybody else in IChemE to IChemE Safety Center for organizing this discussion.
Thanks, Ramin. Pleasure. Robin, your thoughts?
Yeah, very quickly, fully endorse what Ken is saying, that important that we can all make a difference. So the tools and the approaches are out there. So, never feel constrained in trying to make those improvements. And then perhaps one of the cautioning on competence, we've talked about other people's competence. We need also to think about our own competence and sometimes think, am I the right guy to do this? Should I find somebody else who can help me on this? There's the two thoughts.
Yeah. Judith.
I think my closing words would be constant unease has to be our watchword. This job will never be done. There's always something around the corner that we need to be looking out for.
Okay. Wonderful. Well, thank you very much to the panelists. In the chat box, I've actually put a series of links to various things. There's a link to access or to get to the loss prevention bulletin where you can actually download a copy of Ramin's The Nylon Years. There's also a link to the Chemical Engineer. In the upcoming editions of the Chemical Engineer magazine, we have a series of articles coming out about Flixborough. In this current edition, there is an article by Robin that talks about some of the details of the incident itself, as well as an interview I did with Andrew Hopkins, where we do actually talk a lot about culture in that particular interview. So take a look at those. We've got another series of different articles coming out in the coming months as well. Also, I will note that BBC Sounds have just released a podcast on Flixborough to mark the 50th anniversary as well. And Dame Judith, I heard your voice in that podcast as I listened to it today. So certainly you can Google BBC Sounds Flixborough and you will find that podcast and be able to check that out as well. Thank you all very much for joining us today online. Hopefully we managed to get through most of the technological issues. I don't know why some of you couldn't see us on camera, but some of you could. This was beyond my competence. But nonetheless, you could all hear us. So thank you very much for your time and stay safe, everybody.